Title this note, using the sign to name the quadrant. And the first example is, in what quadrant is sine of theta less than 0? And cosine of theta also less than 0. So first of all, we got to think about, well, if sine of theta is less than 0, well, what kind of number is that? What kind of numbers are less than 0? Well, the numbers are less than 0, definitely negative numbers. You might say that, or you might just put a negative sign. And if cosine is less than 0, so again, that's also a negative number. So basically, what you're looking for is, again, or a negative sign. What you're looking for is, in what quadrant it actually happened. Well, I tell my students is use this little chart here. And this little chart kind of tells you what sign is positive, and depending on what quadrant you're in. And of course, we already know this is quadrant 1, this is quadrant 2, this is quadrant 3, quadrant 4. And this A represents all of them. So in this quadrant, all are positive. So in this quadrant, all are positive. And then the S represents sine, meaning that in this quadrant, only sine is positive. And you might just emphasize the word only. Only sine is positive in that quadrant. T represents tangent, so down there, only tan is positive. And the last one, C represents cosine, so here, only cosine is positive. So if that's the case, what I tell my students is all students take calculus, right? So that's my way of memorizing what goes where. All students take calculus. So it's saying that in what quadrant is sine negative? So I can rule out 2 places right now. It couldn't be in quadrant 1 because all of them are positive there. And it couldn't be in quadrant 2 because sine is positive there. The next restriction is cosine must also be negative. But cosine cannot be negative here. So the only place it could be is here. So the answer to this problem is quadrant 3. And that's it. Same problem. Just change things around a little bit. So right now, pause the video and you actually try to find out what quadrant this is in. So pause it right now. So you got started, hopefully you start off by writing this acronym with the quadrants of all students take calculus. And we would decide what sign is this? Sine of theta is less than 0. So this definitely is a negative sign. And then this one, it says cosine of theta is greater than 0. So this is definitely a positive sign. So I'm looking for is cosine, where is sine negative first. So sine cannot be negative here, sine cannot be negative there. The last one I'm looking for, cosine is a positive. All right, so that's not really a T, that's really a plus sign. So cosine could not be positive here, but it's definitely going to be positive there. So this answer would be quadrant 4. So right now, write down this one, pause the video, and try this one on your own. So if you tried it, you should have found, since it says tan of theta is less than 0, you look for where tan is a negative. And you're also looking for when cosecant of theta is less than 0. So basically, if you're looking for cosecant, since cosecant and sine are reciprocals of each other, and you don't have a cosecant on here, you notice it says all students take calculus, and it goes for sine, tangent, and cosine. Since cosecant is reciprocal of sine, you can really look at the sine curve. So you're looking for when it's sine negative. So it goes for all the reciprocal identities, cosecant, cotangent, and so forth. You basically look for when that reciprocal function is negative or positive, whatever the case may be. So in this one we have tan is less than 0. Couldn't be here, couldn't be here. In both of those places, tan will be positive. The next one is cosecant, or even better, sine negative. Sine cannot be negative there, so it has to be in quadrant 4. So answer to this one is also quadrant 4. In this example, you're given cosine of theta is equal to a ratio, and you're given the quadrant that theta is in, and ultimately, we want to figure out what sine of theta is. So I'll start off by drawing x and y axis, and it says that cosine of theta is a negative 4 over 5, and it's in quadrant 2. So if we look at this, here's quadrant 2, and this is my triangle. What we already know is cosine is always adjacent over hypotenuse. So this ratio is telling me that this is the adjacent side, and this is the hypotenuse. So if that's the case, I know my adjacent side is negative 4. I know my hypotenuse is 5. No matter what they tell you about this fraction, the hypotenuse is always a positive length. So if they give you something like a negative number, like negative 1/2, and that negative sign is right in the middle of that bar, be sure to get the negative sign to the 1. And make sure the bottom is positive, because the hypotenuse is always positive. So this is the triangle, given that information. It says find sine of theta. So theta is always a reference angle right here. So in order to find sine in this triangle will be opposite, which is over here, over hypotenuse, which we don't know. So there's 2 ways of doing this. This is one way. If I want to find that, of course you use Pythagorean there, and you would say, well, I'm going to call that x. So you would say x squared plus a negative 4 squared is equal to 5 squared. So you have x squared plus 16 equals 25. So ultimate x squared equals 9. And after you finish doing the math, you find x equals to positive or negative 3. Now this is the thing. After we go back and we make sure our quadrants are in order of all students take calculus, we know the sign is positive right here. So even though we said it's positive or negative 3, we only take the positive one. So our only answer is positive 3. Meaning that this one right here is 3. So if that's the case, we know sine has to be opposite over hypotenuse. So sine in this problem is equal to 3 over 5. So that's the answer for it. In that quadrant, sine of theta has to equal to 3 over 5. That's one way of doing it. We'll talk about another way next. So another way to think about it is, if I constructed a triangle, so there's in that quadrant, what we can always know for certain is this is a y value, this is an x value, and this is a radius. So this would be a negative x value because to the left, but that's what they all are. So basically what we know for certain is sine of theta is always going to be opposite over hypotenuse. So it's always going to be the y value over r. So I could say sine is always going to be y divided by r. If I want to find cosine of theta, it's always going to be adjacent divided by r, the radius. So the cosine of theta, in this case it's a negative x, but it's always going to be x divided by, in general, it's always going to be x divided by the radius. And tan, we didn't talk about in this problem, but if we did want to find tan will be opposite. This is opposite. That's adjacent. So tan will be y over x. So it's always going to wind up being y divided by x. So we look at the reciprocal functions. Cosecant would be reciprocal of sine, would be r divided by y. Secant would be the reciprocal of cosine, so it would be r divided by x. And cotangent, of course, would be the reciprocal of tangent. Now, one thing I didn't tell you how to find is, we can see y, we can always see the x, it's gonna be written right there. But I didn't tell you how to find the r, which is, you use Pythagorean then to find it. So I know that x squared plus y squared is equal to that radius squared. And we solve this equation for r. Ultimately, r is gonna be the square root of x squared plus y squared. So r is always gonna wind up being the square root of x squared plus y squared. If you actually want to find out what r is, that's what it will always equal. So we took a second look at the same problem. I know that this is going to be my x value, and I know this is going to be my r value. So if I want to find out what sine is, then we know the sine of theta, you remember, is equal to y divided by r. And what I already know is the x, and I know the r. So since r is equal to the square root of x squared plus y squared, well, r is going to have to equal to the square root. I know x is -4 squared. I don't know y squared, so it's still there. And I know that r is 5, so it's going to be 5 equals to that. Not squared, just 5. So if you actually want to finish solving it, you probably square both sides of the equation. So basically, when you square that, you would get this side to be 25. And that's going to equal to, when you square root, you only have the radian left. That's the part underneath the square root symbol. So you only have, I'm going to go to square the -4. So it's going to be 16 plus y squared. So you go now to solve for y, so I can know what y is. So of course you subtract 16 and square root it. And after you do that, you wind up having y is equal to you say plus or minus 3. So y could be positive or -3. And in that quadrant, we know that sine has to be positive because again, we're looking in this quadrant 2 right here. And sine is definitely positive there. So we only need the positive 3. So now I know what y is. So I could say 3, and since I know r is 5, I know sine of theta is 3/5. That's another way of doing it completely algebraically. And that's just another way of getting the exact same answer. Here's a new example. You try. Either use the quadrants and draw the triangle for it, or actually try to solve it completely algebraically. Take a minute, pause the video, and try this one on your own. So if you tried the first method, you really came up with this triangle here in quadrant 3, and because my hypotenuse is 41, that would go here, and the opposite is -40. So this is what the triangle will look like. Ultimately, we want to find cosine. So ultimately, we need to know this length. And because that length is going to the left, I know it's going to be a negative length. So I'm going to call that x. But I know when it's all said and done, there should be a negative value for x. So if that's the case, you should want to have this if you use the Pythagorean theorem. From there you're going to get, you can figure out what 40 squared is, or you can subtract. So I will subtract a -40 squared from both sides. Leaving you with x squared is equal to 41 squared, subtract -40 squared. And you really can plug that into your calculator. And when you do, you're left with x squared equals to 81. So of course, x could be positive or -9. We have to decide which one it is. So in this quadrant, all students take calculus. In this quadrant, I know sine, only 10 is positive, so sine is negative there. And cosine is also negative there. And also, because it's going to the left, I know this is a negative length because it's going to the left. So I know it has to be a negative length. So I don't need the positive version, I only need the -9. So cosine of theta has to equal to adjacent, -9, over the hypotenuse, which is 41. So the answer to this one is -9 divided by 41. And that's it.